Question number 8. If for a roll of fair die, each of the outcomes 1, 2, 3, 4, 5, or 6 is equally likely. A red die and a green die are rolled simultaneously, and the differences of the outcomes, red minus green, is computed. This is repeated for a total of 500 rolls of the pair of dice. Which of the following graphs best represents the most reasonable distribution of the differences? Well, all right, let's think about what the outcome is. If you have, on average, you have a roll of dice and you're subtracting those, think about where it should be centered around. All right, think about where it should be centered around. See if you can guess this one. So I've kind of created a sample space. I want you to look really carefully here, okay? Look at my red minus green. I've done a bunch of red die. Started with 1, and I started with the smallest difference I could. So 1 minus 6. So 1 minus 6 can be -5. You can't get a number lower than -5. Try, right? 1 minus 6 is going to give you your smallest value. You can only get that once. Same thing, you can only get 5 once, right? 6 minus 1. Now, what's going to be the most common is 0, because look how many ways you can get that. There's 6 different ways you can get 0. So it's going to be centered around 0, with your lowest value around 5. This is what the distribution should look like. Of course, if you do a simulation, you'll get more of a normal curve type shape, right? But 500 rolls, repeated rolls, you're going to simulate that distribution. And it's going to look very similar, very close to this one right here, because it's centered around 0, and it looks like your min's around -5 and your max is at 5. Where here, you can't get a difference of 6. That's impossible, right? And here, you can't get a difference of 12. That's sum. This is sum. This is difference. So it's going to be C. All right, you see that? Visualize your sample space, and then see if that simulation matches it.